Good day, viewers. In the previous video, we measured 150 block and 25 block on the ground floor. So the measurement of block on ground floor and those block on first floor, they are the same. The measurement process is the same. So for that, I'm not going to measure the block wall on first floor. You can try that out yourself. The measurement process is the same. Just take note of the openings, the door opening, the window opening, and the lobby openings. Then you deduct them from the total measured wall area. So in today's video, we are going to measure the next item after block wall, which is roof. So we're going to measure roof in today's video. The roof. Okay, let me check the roof on this video. The roof on this video is how will I put it like this now? It's a hip roof. It's a hip roof, and it's somehow complex. So I want to start with this. I want to measure something that is simpler than this, so you guys understand the basic process of measuring roof. So after that, I want us to measure a monopitch roof. So after we've measured the monopitch roof, we will measure gable roof. Then we will now measure this particular roof as the last series on roof measurements. I want to start with this, so you guys understand the whole process. So I'm going to upload another roof drawing, a monopitch roof drawing, and we'll measure the required item. So let me quickly add that drawing to this particular drawing. Okay, so at the end of this video, I will add the link to this particular drawing to the video description on my channel, so you guys will have access to the drawing. Okay, so we have our drawing uploaded already. So under this particular folder, I have 4 drawings here. This is also a story building. This is the furniture layout on first floor. So this is the floor before the roof itself, and this is the roof plan, the section through the roof. Like I said earlier, it's a monopitch roof, slopes one direction, and this is section through the roof, another section through the roof. This is longitudinal section, while this is transverse section through the roof. So we are going to measure the drawing. Sorry, I'm going to measure the roof using these drawings. Okay, I think we have our folder created already. Okay, we have our roof folder here. So all our measurements will be under our roof folder. The first thing we're going to do is to dimension. I will have added another drawing aside this. This particular distance is not dimensioned, and we'll have to measure our our wall plate on this particular plan. So what should I do? Okay, let me quickly add that drawing to the drawing I uploaded here. Let me quickly do that. Okay, let me add that drawing. The first floor plan. So what we have here. The first floor plan. Okay, let's check. Okay, so we'll have our first floor plan. Let me do this. This particular plan is now useful. Yes, okay. Okay. So we have different roof member. We have different roof member. Some of them are listed here. We have the purlin. So our roofing sheet will be attached directly to the purlin. This is the rafter. Our purlin will be attached to the rafter, and the other member here is the tie beam. The tie beam here it serve as like the base. What we have here is like a triangle. What we have here is like a triangle. What we have here is like a triangle. So the base of this triangle is the tie beam, while the upper part here, which is the hypotenuse, is the rafter. And on this rafter we have purlins spanning across the rafter. And between this rafter and the tie beam, we have these roof members here. This roof member here. They're like brace. Yeah. So those roof members they are called the struts. And the last um, item here in the last item here is the aluminum roofing sheet. The roofing sheet itself. The aluminum roofing sheet. Um, they didn't label the what's it called, the wall plate here. So in every roof we have wall plate. Wooden roof will have wall plate. So the whole roof member will rest on the wall plate, while the wall plate will rest directly on the building. So those roof members will not rest directly on the building. They are going to rest on the wall plate, while the wall plate will rest directly on the building. So the wall plate is not shown here, but that's the first item I'm going to measure. So measure the wall plate on our first floor plan, because the wall plate will be resting directly on the building. And the numbers of wall plates you have in the building is going to be to the discretion of the estimator, and the discretion of the person that is going to construct the roof. There's no specific number of wall plates. No specific number of wall plates. So, but what we're going to do here is that we'll measure wall plate along the length of the building, both on the front part of the building and on the right part of the building. So we're going to have two wall plates here. We'll have a wall plate here, and we'll have another wall plate spanning from this point to this point. And okay, maybe we should add one to it. We might just measure wall plate across this wall. Although the wall did not cut through. We're going to measure our roof with the aid of the basic tools on PLANSWIFT, like I said. We're going to measure our roof with the basic tools on PLANSWIFT. So we're going to use our linear tool to measure some part of some roof member, and we'll use area to measure other roof members. Should I show? Let me look for a detailed roof drawing. I'll show you guys a roof member before we measure. Okay, this member here that form the base of the triangle or the right angle triangle, as the case may be. For monopitch, it's usually right angle triangle, but this is a triangle now. This is a gable roof. This member here is the tie beam, while the member at the top here, this member is the rafter, while this they are strut. This is the king post, since this is a gable roof. While this particular member here that spans across our rafter is the purlin. Okay, like that here too. So this is the purlin, that's the rafter, and okay, same thing here. Okay, same thing here too. This is our wall plate. The whole roof member will rest on the wall plate, while the wall plate will rest directly on the roof. Let's go back to our drawing. Okay, back to our drawing. We're going to measure the first member. We're going to measure is the wall plate. I'm going to measure our wall plate using our linear tool. But before that, we have to scale this drawing. So I'm going to scale this. I'm going to use the scale 22.875. 22.875. 22.875. And we'll also scale this other side. 12.915. 12.915. Okay, let's cross check our scale. This should give 5.4. Okay, I think we are good. So let's quickly measure our rafter, our plate, which is the first member. So I'm going to measure our plate with the aid of our linear 2. Linear 2. Most roof members are measured in linear meter except the roof covering. So I'll rename these as wall plates. Wall plates. And this particular measurement will be in our roof folder. So like I said the other time, I want to measure wall plates along the rear part of the building. Next. And this part too of the wall plates along this part. Let's add another wall plate to this. Although this is not spanning through inside. Escape. But for most structure, once your structure is once the width of the distance is more than 12 meters, this is more than 12 meters, especially for industrial buildings and all of that. Usually, it's advisable that you make use of steel roof instead of wooden roof truss. But I want to have on this plan. It's a wood, not steel. So I'm going to measure it that way. With this, we're done with the first item, which is the wall plate. Let's measure the other items. After wall plate, we're going to measure our tie beam, and we'll measure tie beam and rafter. If you check this roof section, they didn't state the spacing. They didn't state the spacing. But for measurement purpose, we're going to make use of 1 2 center to center spacing. 1 2 center to center. So if you want to make use of 1 2, we need to calculate the numbers of setup we have, because the rafter alongside tie beam and the strut, they are like a they are an entity. Let me put it that way. They are an entity. So you have this same setup here at intervals of 1 2, or the case maybe it's more than that or lesser than that. But we're going to assume that the spacing between this setup and the next will be 1 2. They didn't state it here. So, but normally it should be stated. They didn't state it. So that means since our distance is going to span this way, if you have a setup here, after 1,200 meter, we'll have another setup. After 1,200 meter, we'll have another setup. That way, along the length of the building. So, but this is complete setup. Since they didn't specify, like I said the other time, let's assume 1,200. Let's calculate the numbers of setup we have. 1,200. The length of this building is what? Let me check. Where is our floor plan? Okay. So the length of this building is 2,875. 2,875. 2,875. You know, I didn't use this length. I didn't use this length because your setup, the normal thing is that your roofing sheet will, like it will, how let's say it will span beyond the building. And let me put it that way, it will span beyond the building. So if, for instance, our block was along this side, this way, we'll have that extension called the eve projection. The eve projection. So that serves as protection for the wall, serve as protection from the wall, from rain and all of that. So we'll have that extension. So if I should make use of this, at the end of the day, the numbers of setup I'll have will be more than the numbers of setup that is required, because the whole setup will be on the building itself. It will have extension beyond the building. So the extension, for the extension now, it is the distance that will extend beyond the building. The um the rafter and tie beam will extend beyond the building, but the setup itself will not extend beyond the building. Like the element of the setup will be on the building. So I'm going to make use of the length on our plan, on our first floor plan. I'm going to make use of this length. I'm going to make use of this length instead of the length on the roof plan. So this length is 22,875. Let me use my calculator. Calculator. Okay. 22,875. 22,875 divided by 1,200. So that's 1.2 meter spacing. So that means we'll have approximately 19 setup of rafter, tie beam, and strut. 19 setup of rafter, tie beam, and strut. So now let's go back to our roof section and we are going to measure. Okay, but before then, we have to scale. That's one thing. We have to scale this drawing. Let's use this scale. 22.05. 22.05. 22.05. Okay, 22.05. Let's confirm, or let's scale this vertical dimension 9.615. 9.615. And let's cross check our dimension before measurement. Okay, I think our dimension is accurate. So let's measure. The next item is the tie beam, which is the bottom member of the setup. The tie beam. I'm going to measure that with the aid of our linear tool. Tie beam. Don't forget that we calculated the numbers of setup the other time and we got 19. So that means we'll have 19 tie beam along the length of the building. So I'm going to multiply whatever length we get from this by 19. And in doing that, you can do that directly, even before measurement. Just click on advance. Then under estimating, locate quantity. Quantity, takeoff. The takeoff here is what you are going to measure. Whatever you are going to measure, it's the takeoff. So we want to multiply that takeoff by 19 because we have 19 numbers. So you click on this takeoff and you click on the multiplication sign here and you input 19. So with that, automatically multiply whatever we have here by 19. Then I'm going to click on OK. And with that, I'll trace this from this point down to this other point. Okay, oh, sorry. This should to start from this point, from the external part of the building, because it's going to rest on the wall plate. So let me remeasure it. It's going to rest on the wall plate. To start from this point down to the center point. Escape. Okay. So with this, we are done with measurement of rafter. Sorry, of tie beam. The next member I want us to measure is our rafter. Our rafter. I didn't even include the what's it called? The this in the description. The size in the description. This tie beam is 750 by 100. Let's do that. Take out some 750 tie beam. 750 75 by 100 mm tie beam. Okay, so the next member is our rafter, and our rafter is 50 by 100. 50 by 100. I was still going to measure our rafter. We need our linear too. 50 by 100. 50 by 100 mm rafter. Like I said, our rafter will extend beyond the building. The setup itself will not extend beyond the building, but the rafter will extend beyond the building. The rafter and the purlin will extend beyond the building. Okay, and we forgot to multiply this by what is it called? By 19. So let's quickly do that. So you can always correct your measurements. Multiply by 19. Okay. So measured. The last member here is the rafter. Sorry, the strut. And from this description, our strut is 50 by 75. 50 by 75. I'm also going to measure that strut with the aid of our linear tool. 50 by 75. 50 by 75 mm strut. So we're going to trace the strut. You will have it here, right from this point, from the bottom of the tie beam down to the top of the rafter, down to the bottom of the tie beam, to the top of the rafter, to the bottom of the tie beam, to the top of the rafter, bottom of the tie beam, top of the rafter, bottom of the tie beam, top of the rafter. So I'm going to measure it that way until we get to the end. So with this, we're done with this particular setup. The next item we're going to measure is the purlin, the roofing sheet, and as the case may be, I don't know if we're going to use what's it called, asbestos ceiling finish, or the PVC ceiling finish. We'll have ceiling noggins inside the building. We'll have ceiling noggins. So I'm going to measure that. We are just going to assume that we are going to use PVC ceiling finish. So I'm going to measure the noggin too. So we'll continue from the next video. Let me cut this video.